Hey guys, we're going to do a video here for Chapter 4, Section 1, which is our chapter where we start learning about inequalities. So, the essential question in this lesson is how can you use a number line to represent solutions of an inequality? So we're going to be looking at number lines and solutions and how to show that, basically. So to kind of get us started, I guess the main idea is that word inequality, and I'm going to write that on the left side, inequalities. And this shouldn't be a brand new concept for a 7th grader. You've heard this word before, you've worked with this a little bit, but we're going to make a table in our notes just to kind of review. So first off, there's some symbols you need to know, and there's some key phrases. So we're going to make a pretty big table in your notes where it says symbol and key phrases. Pause the video at any time if I go a little too fast putting this table together. But we're going to set this up, and we're going to look at each symbol that's kind of important to know. So, okay, let's kind of start with the first symbol here. Here's the first symbol. We call this the less than symbol. So if something is less than, we'll often use that. Another key phrase you might hear is fewer than. So you might be like reading a story problem or reading a situation, and you'll hear the words fewer than, and hopefully you'll kind of be like, oh, it sounds like an inequality, like a less than symbol. I'm hoping. The second symbol is the opposite of this. It's the greater than symbol. And another key phrase you might hear is you might hear the words more than. So again, pause the video if this is a little too fast to write it all down, but more than is another way of saying greater than. So that's a key phrase. And then here's our third symbol. It's basically the less than symbol with a line underneath, which represents an equal sign. So it's less than or equal to. It's when we have more options. So less than or equal to, some key phrases if you're reading a story problem is you might hear the words at most. And this is a trickier one. If you say like, oh, at most, it means less than or equal to. You might also hear the phrase no more than. So no more than kind of means the same thing. And then the flip side of this is the greater than or equal to sign with the line underneath. So greater than or equal to in a story problem or a situation, you might hear the phrase something like is at least, like, oh, is at least is another way of saying greater than or equal to. And really, if you kind of stop and think about that, like if I said like, I know a student named John and he has at least 10 pencils in his locker. Think about that. He has at least 10 pencils. So in his locker, he's got 10 pencils, or maybe he has 12, 13, 14, 50 pencils in his locker. He is at least having 10 pencils in his locker. So anything equal to 10 or greater than it. So you just kind of have to sit and think about those words sometimes. Another key phrase you might hear is no less than. So John has no less than 10 pencils in his locker. Okay, well then he has 10 pencils or more is what that means if it's no less than. So you just got to think about that phrase. The reason we're kind of reviewing this is because math is kind of its own language, and we talk about that in class sometimes. We have, English and Spanish and French and all these different languages that people learn, but math is the language of numbers, and so we kind of have to translate math to English and English back to math pretty frequently. So here's a really good example of a math sentence. It says b plus 3 is greater than 22. Now, I don't know what b is at the current moment. I could figure it out, but I just want to practice translating this into like an English sentence. How would we say this? So because b is our variable, it's a number. It's just a number that I don't know yet. So we have a number plus 3, but when I say plus, here's a way I could translate the word plus. I could say and. A number and 3 is 3. So a number and 3. And then we've got our symbol. A number in 3 is greater than 22. There's our English sentence. A number in 3 is greater than 22. So you can see why I like math. I like the short, simple version. B plus 3 is greater than 22. But we want to be able to kind of go back and forth between words and numbers and symbols and feel very comfortable with that. So we're going to try this problem, the first example for this video. And for our first example, we're going to translate this sentence into a math sentence. So it's a number q plus 5 is less than or equal to negative 7.9. And I'm not asking to solve this problem right now. I just want to translate it. So a number q, okay, I don't know what q is, but I'm going to write that down, q, plus 5. Oh, well, that means I have to add 5, plus 5, is less than or equal, okay, so use the right symbol, less than or equal to has the line underneath, to negative 7.9. Oh, okay, so negative 7.9, there's my math sentence. Later on, we'll solve it, but for now, I'm just translating. So you can see, like, we're trying to go back and forth from words to symbols and numbers, and back to words again sometimes. So your turn. I'm going to have you guys try one. And here are your two problems. There's an A, there's a B. I want you to pause the video and test yourself and see, can you translate these sentences? So the first one says, a number x is at most negative 10. Try to translate that. Go ahead and pause the video now and give this a try. Okay, I'm hoping you're unpausing the video and you've tried both problems. Now we're going to go over the solutions here. So starting with A, a number x is at most negative 10. Is at most. So it can't be more than negative 10. It can be less than, but not more than. So here's my translation. X is less than or equal to negative 10. Let's look at the next one. Twice a number y is more than negative 5 halves. Twice a number, so what does twice mean to do? Hopefully you multiplied it by 2, that's what twice means to do. Twice a number y, so 2 times y, basically, is more than negative 5 halves. So 2y, it has to be greater than negative 5 halves. There's my translation. And I hope that's what you got too. So here's the next step. We're going to do a second example now. Besides translating, we want to be able to do something else as well. We want to be able to tell whether negative 2 is an actual solution to an inequality. Now, negative 2 is a random chosen number that I just want to test and see. Is it a solution or is it not? And the inequalities I'm going to look at, I'm going to do two different problems. I'm going to have a part A and a part B. Here's part A. Y minus 5 is greater than or equal to negative 6. And my question is negative 2 a possible solution to this problem? That means, could y be negative 2 and this works? Would it be true? So what we're going to do is underneath the equation, the inequality, we're going to represent this by putting negative 2 in. And instead of y minus 5, I'm going to have negative 2 minus 5 is greater than or equal to negative 6. Okay, let's do that math real quickly. Negative 2 minus 5, well, that means you have 2 negatives and 5 negatives. You have 7 negatives, so negative 7. So the real question is it greater than or equal to negative 6? Because if it is, then we know it's a solution, and if it's not, then not so much. So is negative 7 greater than negative 6? Think on a number line, zeros in the middle, you're going out to the negatives. Negative 7 is farther out than negative 6, so not greater than negative 6. So no, I'm going to put a slash through my inequality. This is not a true statement. And my answer is negative 2, the number we tested, is not a solution. It does not work in this problem. We tried it, didn't work. Let's try it on another inequality. How about this one with a decimal? Negative 5.5y is less than 14. Same question, is negative 2 a solution? So I'm going to replace the y with a negative 2 and see. Let's test it out. And so I'm going to take that negative 5.5 and times it by negative 2 and see if it's less than 14. Now, if you need a calculator, you could use one. It's a decimal, but hopefully you don't need a calculator on this. We know a negative times a negative ends up being positive. And we know 5.5 times 2, if we double it, is going to be 11. So we have 11 is less than 14. So again, in your head, you say, is that true? Is 11 less than 14? Absolutely, 11 is less than 14. This is true. So negative 2 is a solution to this inequality. So we found an answer. All right, you try. Again, I'm going to have you pause the video and see if you can tell whether negative 5 is a solution to each of the inequalities I'm going to show you. So here are your two problems. There's going to be an A and a B. Pause the video and test out negative 5 to see if it's a true solution to these inequalities. Go ahead and try. Okay, let's check our answers. You're unpausing the video now and you're ready to see if you're doing it correctly. So we're seeing if negative 5 works. So we're going to replace the x with a negative 5. So instead of x plus 12, we have negative 5 plus 12 is greater than 7. Well, we can do negative 5 plus 12, that's 7. Is 7 greater than 7? And hopefully you're saying no, it's equal to, and there's no equal sign, so this one fails. Negative 5 is not a solution, it doesn't work. But we try it again on the next one. We put negative 5 in. Okay, this one you have to be kind of careful with your negative signs. We know that the 2 times 5 is 10, but 2 negatives makes a positive, so it's 1 plus 10 is greater than or equal to negative 9, and 1 plus 10 is 11. And is 11 greater than negative 9 or equal to, greater than or equal to negative 9? Of course 11 is greater, it's a positive number. So yes, negative 5 is a solution. This one did work. I hope that's what you got too. Okay, so moving right along, here's our third example now. I'm kind of throwing a lot of things at you in this video, but I'm hoping you're with me on this. Now we're going to graph our solutions. This is kind of what we're building up to. We want to graph a solution for this. X is less than 3. So I want to think about this. If x is less than 3, I don't know what x is. It's my mystery number, but it has to be something less than, something smaller than 3. There's a lot of options. Think about it. It could be 2. That's less than 3. It could be 1. It could be 0. It could be a negative 10. It could be a negative 100. What if it's 1.4? What if it's a decimal? There's so many options that x could be. So to show our answer, we're going to use a number line. A number line is going to show all those possibilities. And when you draw your number line, you're going to use a ruler or use graph paper and make it really nice and straight and neat. You don't want sloppy, messy number lines. That's not a good thing. You want it nice and clean. I'm going to put 0 in the middle. I'm going to go 1, 2, 3, 4, 5. And I'm going to put some negatives on there. Negative 1, negative 2, negative 3. Then I'm going to focus on what's going on in this problem. X is less than 3. So let's circle 3. That's kind of our point that we're focused on. Let's think about x is less than 3. We're going to test both sides of that point. So if I pick the right side, I could pick any number on the right that I want. I could pick 4, 5, I could pick 100. But I just want to see, is it a true statement? Is 5 less than 3? And in my head, I'm like, no, 5 is not less than 3. That side's not going to work. Pick something on the left side, like, I don't know, negative 1. This is a random choice. I could have picked anything on the left. Is negative 1 less than 3? Yes, totally. So the left side of the number line works and the right side doesn't. So what we do is we take our pencil and we just shade to the left. Some people like to use a colored pencil. Some people just use the side of their pencil and do some shading. But we're going to bold that side of the number line and do a big arrow at the end, because this thing's going to keep going. Anything to the left is going to count as a solution. Now we do have one more thing to do before we're done with this number line. We need to test the actual point that we circled. 3. Is 3 less than 3? Now, I have to know 3 is equal to 3. So what we're going to do, since that fails, we're just going to leave the hole empty on the graph. We're going to circle it, but leave it empty so that everyone knows, hey, it's not equal to 3, it's just anything less than 3. And that's our solution on a number line. So an empty hole. Okay, so let's look at another one. Let's do an example 4. We're going to do the same thing. We're going to graph the solution. But this time when we graph, we're going to graph m is greater than or equal to negative 2.5. I'm going to go for a decimal on this one. So m is greater than or equal to negative 2.5. Okay, so first step, number line. So we're going to draw our number line. Same idea. Use a ruler, straight edge, make it nice and clean and neat with arrows on both ends, because the number line goes forever, both directions. Get 0 in the middle. 1, 2, 3, 4, 5, and some negative 1, 2, 3, 4, 5s. And then we're going to circle the point that we're most concerned about. It's negative 2.5. So negative 2.5 would be between negative 2 and 3. So I'm going to circle it. Then I'm going to do the next step, which is test both sides. I'm going to test the left and test the right. So pick anything you want on the right-hand side. 2. I'm picking 2, but you can pick anything out there. You can pick 3, 4, 5, anything. And I'm going to see, does it work? Is 2 greater than or equal to negative 2.5? And hopefully you're like, yeah, 2 is greater than it. So true, yes, that side works. Now test the left-hand side. Pick negative 4, for instance. Is negative 4 greater than negative 2.5? No, negative 4 is not greater than negative 2.5. That side fails. So we're going to shade with our pencil to the right because that was the side that passed. And we'll make a big arrow on the end of the number line because it's going to keep going to the right. And we'll shade it real nice. Maybe some people like to use highlighters also. Like, you can use whatever tool you have to kind of show that that's the solution. But don't forget, we have to test the actual point itself. We have one more test to run. Is negative 2.5 greater than or equal to negative 2.5? It's not greater, but it is equal to, and there is an equal sign. This one passes. So instead of leaving it that empty hole, we're going to shade it in, making a dark, solid hole so that when someone sees my number line, they know that I know it's a solution. So there's my solid point, all filled in. There's my graph. All right, so that's kind of the basics, guys. I'm going to have you try it one more time here for this final piece of the video. Can you try some graphing? And this is what I'm going to give you to try. 3 different problems. You're going to make 3 different number lines. So you're going to have to pause the video and really take a few minutes to draw out each number line. Those of you that are kind of sloppy and messy when you're writing, you're going to have to push yourself to try to be nice and neat and organized with this. If not, when we get into more complicated problems, those messy number lines are really going to be kind of a challenge. So go ahead and pause the video and see if you can draw 3 different number lines that represent these inequalities. Okay, so you're unpausing the video now. You're ready to check your answers. You have 3 different number lines, I hope, and we're going to see if you are correct. So here's the first one. X is less than negative 1. You should have had an empty hole in negative 1 because it's not equal to when you tested it. And you should have ended up shading to the left. This number line is not as clear. You can tell that it's shaded left and not right. For z is greater than or equal to 4, you should have a solid point on 4. It should be filled in because of the equal sign and shaded to the right. Everything greater than 4. And then the last one's kind of tricky because it's negative 1/2 is less than t. So when you test your points, here's negative 1/2. T is going to be anything on the greater than on the right-hand side, but there's going to be an empty hole. So you should have shaded to the right and have an empty hole. And those are your 3 number lines. All right, guys, so that's kind of the basics here of how to use the symbols, how to translate English to math, math back to English, and then really just how to place these solutions on number lines by testing points and shading left or right, empty hole versus solid hole. We're definitely going to go farther with this in class. We're going to be solving these and doing way more with them, but kind of an intro video just to get Chapter 4 started. All right, thanks for watching, guys. See you later. Bye.